Welcome to one of our very first videos of the year talking about the real number system. One thing I like to always say is the numbers you're going to see in algebra, unless noted otherwise by your teacher, are all real numbers. Real numbers surround us everywhere in Algebra 1, and when you move up onto Algebra 2s and your pre-calcs and calculus, then you'll start to understand and see where there are numbers that aren't necessarily real. And I know it sounds really weird, but there are numbers and they are very helpful in certain calculations that are not exactly real. And again, I don't want to get too far into that because I don't want to open something that we don't need to know about, but we're just going to talk about real numbers for right now. So when you look at real numbers are classified into two categories: irrational and rational. So one way to do this is to make a nice big circle, and you let this circle represent all of the real numbers in the world. So any number in here is a real number. The real numbers are split into categories irrational and rational. Irrational is like the one weird classification that's kind of off by itself. Now I can't put it outside the circle because it is technically real. So a lot of times you see it as its own circle off to the side and written as irrational. So this circle represents all irrational numbers, and we'll talk about them towards the end here because the other numbers are easier to talk about. And so if irrational is there, then everything else in this circle is rational. That's because a real number is either irrational or rational. They're opposites of each other. Then we have the integers. Inside that, a smaller category of number. Inside the integers are the whole numbers. And then inside the whole numbers, the smallest category we're going to talk about are the natural numbers. Now, a little bit about all of these numbers before we move on to the next thing is, what are they exactly? Natural numbers, and all of these classifications go on forever, but the natural numbers is the smallest category. That's why it has the circle all the way on the inside here. Natural numbers are represented by a capital N, and it's a fancy looking N where you kind of throw a double bar in there. So it kind of looks, it's an N, but we have a little bit of double slash over there. Natural numbers are the numbers you would count as if you were counting something. So when you count how many markers are on this paper, you wouldn't say 0, 1, 2, 3. You would start at 1, 2, 3 markers. And so just like that, with the natural numbers, you start with the number 1, then you go to 2, 3, and you go on forever, like you would count. The only difference when I go from a natural number to a whole number is adding a 0. So the whole number, it's a fancy W. Just like the N, it has a double bar here, just on the left side. And so it looks like a W, but just a little bit different on the side there. And the whole numbers, like I just said, all the exact same numbers as the natural plus 0. So 0, 1, 2, 3, and they go on forever. Then we move to the integers. And the integers, not a fancy I like you might think. The integers are actually represented by a Z. Now it is a fancy Z, and so I kind of draw it with a double bar down the middle like that. So here's your Z. And the integers are all of the whole numbers and their opposites. So we would have the 0, 1, 2, and 3, and it would go on forever in the positive direction, but it would also include -1, -2, -3, and it would go on forever in the negative direction. If you notice, haven't had any fractions or any decimals yet. All just nice numbers that you would typically count by, maybe integers you started to learn in your last year of elementary school, natural and whole numbers you've been dealing with for your entire life that you can remember. But now we're going to introduce the numbers most students don't like. They're those fractions and decimals. So rational numbers. Rational numbers are represented by a Q. And sometimes you might see it as a fancy Q, but it's essentially just a Q, just like all these other letters. And a rational number is anything that can be written as a fraction. So anything that can be written as a fraction. Now, anything that can be written as a fraction also includes the categories repeating numbers and repeating decimals and terminating decimals. Meaning, repeating, they go on forever, like 0.11111, or sometimes you see it as 0.11 with that repeating bar. Terminating, meaning they end, like 0.375. It stops. There's nothing that goes on with that. And then you have the last category, like I said, kind of off by its side here. So irrational numbers, first of all, doesn't have a fancy symbol like the Q, the W, the N, or even the Z. Irrational isn't really represented. Sometimes you might see it as IRR, but oftentimes it's written out, and because it doesn't have a symbol. Irrational is the opposite of rational, so it cannot be expressed as a fraction. Most common irrational number? Pi. That's the number most students recognize as irrational, or the square root of a non-perfect square. So, a perfect square is like 9, 25, 100, 900. A non-perfect square are numbers like 2, 3, 5. Something that can't be multiplied by itself to get. Again, 9 is a perfect square, and I'm running out of room here, but 9 is a perfect square because 9 is 3 times 3. The same number could be multiplied by itself. 25, a perfect square, because 5 times 5, the same number multiplied by itself. There are no numbers that multiply by themselves to give you 3. So, 3 is not a perfect square. Alright, with all of that information, let's see if we can do some classification. So, let's look at just the top half here, ignoring this bottom portion. If I want to classify this set of numbers, and you know it's a set of numbers because it's written in set notation, these fancy curly braces here, and I have 1, 2, 3, 4, 5, 6, 7 numbers here. Remember our fancy symbols: N for natural, W for whole, Z is integer, Q is rational, IRR, remember I said I'll represent that as irrational, and the one I didn't tell you about, the fancy R, that's the one you probably know about already. That stands for real numbers, or all real numbers. So, natural numbers would include 1, 2, and don't get tricked, but the square root of 9 is just 3. So that would also be a natural number. Then when I go to the whole numbers would be all of those natural numbers, and if I happen to have 0, which I do, 0 is a whole number. Integers would be all of the whole numbers and any negative whole number. So like -5, without that negative sign it would be a +5. 5 would be a whole number, so -5 is an integer. Rational would be all of these that I've talked about so far. So 1, 2, square root of 9, 0, -5, and any decimals that end 5.43, anything that was written as a fraction, or any decimal that would repeat. Irrational is the opposite of rational, so when you look at your set here, anything that you didn't name for rational would be irrational. Pi being the one here. And then real, well, remember what I said. Remember looking at this chart. All the numbers in this chart are real. So that means all of these numbers are real. Alright, maybe you want to pause the video and try and do this second example by yourself. You can see I have the number -10.7, square root of 22, 212, the fraction 5/3 or 5/3, 44, and -1. So I've got 6 numbers there. We're going to continue going, and we're going to start to classify these. Any natural numbers? Well, no, that's negative. And in natural and whole numbers, what's special about those is they're always positive. So you see that negative number, definitely not natural or whole. Square root of 22? 22 is not a perfect square, so I know it's not going to be natural. 212, that's a number I could count to. 212 is definitely natural. 5/3 is a fraction, so that's not natural. 44 would be a natural number. At -1, again, I see a negative number, so that's not natural. Now, the only difference between whole and natural would be if I could add the number 0, but 0 is not part of my set here, so it's the same exact numbers. Integers, don't get confused. It's not any negative number, because this is a negative decimal, and decimals are not integers. So I can't include that. Square root of 22, still not included. I'm going to include the 2 numbers from above, definitely. 5/3 is a fraction. I don't want to include that yet, but I can definitely include -1. -1 is an integer. Rational numbers would be anything I included from before, and any decimals, even if they're negative, that end, that's a terminating decimal, or fractions, 5/3. And then irrational would be anything that's not rational, and since I have 5 numbers there, that means there's 1 left over. I didn't use square root of 22, that would be irrational. And so then when I get to real, real would be all of the numbers listed above. That's always the easiest one to classify. Everything you're going to talk about in Algebra 1 would be a real number, unless your teacher feels you guys can hear about these numbers called imaginary or complex, which would be completely different. But for right now, let's stick to the real numbers, and don't forget your circle here. Thank you.